For which values of x is f decreasing? For which values of x is f decreasing? So we look at our function from left to right, right? We're not from right to left. Let me show you what I'm emphasizing, that from here going there, x is not decreasing, right? Because we look at it from left to right, we actually have to go that way in order to see whether it is decreasing or increasing. So here x is, well, not x but f is increasing. It decreases until it reaches a, which is a stationary point, right? A and b are the turning points. It is neither increasing or decreasing at a and b. But let's look at what happens between a and b. Clearly you can see that it is decreasing here from a to b, and then when it reaches b, it turns, hence turning point, and it starts increasing once more. It has a positive gradient, and here between a and b, it has a negative gradient. So we say that it is decreasing there. So the answer to 9.1, for which values of x is f decreasing? F is decreasing between 1 and 5/2, right? The x value of a and the x value of b. That's where it is decreasing. In between, at a, it is neither, it is stationary. At b, it is stationary. It is decreasing between a and b. So we're not supposed to include 1 and 5/2, which I think probably, most definitely, some people did include those 2 points. But if you think about it, we're not supposed to include them. The function is stationary at a and b. That's why the turning points are sometimes called the stationary points. Okay, so that is 9.1. What about 9.2? Write down the x-intercepts of f prime, the derivative of f. So the x-intercept, right, is at the turning point. The x-intercept is at the turning point. So when x is equals to 1, we have an x-intercept, and when x is equals to 5/2, we have an x-intercept. So the coordinates, right, of the x-intercept, we're going to have x is equals to 1, y is 0. X is equals to 5/2, and y is 0, right? So that is how it works. The stationary points of the cubic function will give you the intercepts of the derivative, which is the quadratic function. So that is 9.2. And then 9.3, for which values of x is f concave up? So take a look at this. Take a look at this. From here, right, up until somewhere in between here, somewhere in between, it is concave down, as we can see. But the concavity changes. And then now it becomes concave up from this part up until infinity. So we need to find this point where the concavity changes. It is called the point of inflection. How can we find that point? We can say that x is equals to x of tp1 plus x of tp2, right, divided by 2. That's where we're going to find our point of inflection. So x is equals to 1 plus 5/2 divided by 2. What do? I put that in my calculator. So 1 plus 5/2, everything divided by 2. I'm getting 7/4. So x is equals to 7/4. So this point that we're interested in between a and b, it is 7/4. So we're looking for the values of x for which it is concave up. So from 7/4 up until infinity, it is concave up. So what are we saying? We're saying that x can run from 7/4 up until infinity, that is 9.3, right? And then it is concave down from 7/4 up until negative infinity. Okay, but at 7/4 it is neither concave up or concave down. It's confused. It does not know what it is. It cannot identify as one between the two. That is 9.3. And then 9.4, the question that we've done countless times. maybe let me not say countless times, maybe 5, 6, 7 times, something like that. But then why am I bringing that up? Let me show you why I'm bringing that up. We are looking for the value of k for which y, okay, I'm not supposed to do that. Let me go down. For which y is equals to f of x plus k as 3 positive x-intercepts. We're looking for the values of k for which this thing will have 3 positive x-intercepts. So let's dissect that. Let's make sense of that and see what we need to do. So as you've seen on the previous video, when we are doing this question, let me trace the function first so that I can demonstrate it to you with a bit of clarity. So you will see why I'm doing that. You will see why I'm doing that. So I want to show you something. Okay, so this is f of x, right? What does plus k do, right? Plus k, it moves the function up and down. If k is positive, it is pushing the function up. If k is negative, it is pushing the function down. That is what k does, right? So do we need the function to go up? No, we don't need the function to go up, because if it goes up and up and up, we are always going to have one negative x-intercept, and we are looking for 3 positive x-intercept. So how do we get to 3 positive x-intercept? Take a look at this. Okay, we take this down. How many intercepts do you have? 1 negative. We take it down once more. 1 negative. We take it down. 1 negative. Again, 1 negative. But when we reach this point, right, when b touches the x, the x-axis there, we still don't have 3 positive. But take a look at this. What happens there? Now we have 3 positive, right? Let me show you why I'm saying we have 3 positive. We have this positive 1 here. We have another positive intercept here, and we have the third one there, right? So when k, which takes the function down. So if k, we have plus k here, so we need to be careful with how we write this. If k is greater than minus 8, our condition is satisfied. If k is greater than minus 8, our condition is satisfied. Because, for instance, if k is minus 8.5, then we achieve 3 positive intercept, right? But it does not end there. There's a limitation that I need to show you. So let's say we keep going down, and the x value at a touches the x-intercept, because we would have a here, right? And we would have b here. So you can see that when that, not the x value, but the y value, when that y value at a touches the x-axis, we have a problem. We no longer have 3 positive. So we need k to be greater than minus 8, but we need k to be less than minus 9. If these two conditions are satisfied, then we're going to have 3 positive x-intercepts. That is question 9. There we go. Which question do you want me to do next? Question 10, 11, 12? Do we go to 7? Let me know in the comments. Hey, if you think about this, doesn't make any sense, right? Because minus 9 is less than minus 8. These are not positive numbers. So we're not supposed to write it in this way. We're not supposed to write it in this way. Rather, we're supposed to say that k should be less than minus 8, but it should be greater than minus 9. This is the correct way of writing it, because minus 8 is greater than minus 9, right? Not the other way around. I hope nobody made that mistake that I just did there. But anyway, stories.